Hello, this is Maths with Lemon, and in this example we will see the one application of the unit vector. A particle has a position vector 3i plus j when t is equal with 0 and is moving with a velocity of 10 meters per second in this direction. Find first the position vector at t time. Now first let's make a graph and let's see where is that particle. It has a position vector of 3ij, so basically 1, 2, 3 and 1j up, let's say here. So this is the position vector of the particle. Then they tell me that it is moving with a velocity of 10 meters per second in this direction. Let's say that this direction is something like that. Now the particle is moving in this direction but has this velocity. So if I will want the first question asks the position vector at t time. Now you have to understand that basically they ask me to write a position vector of that particle knowing that the velocity is 10 meters per second. Now let's see that how I could do it, how I would write the particle, the vector equation of the particle. It would be the position vector of the particle, which is 3, 1, plus t times a direction vector. Now normally you would put this vector here, 3 minus 4, but it doesn't say that this is the my direction vector of the particle. It says it's in the same direction, but they give me the magnitude basically of the velocity. They give me the velocity basically. So what should I do? Of course I have to here put the unit vector of my particle times this quantity. So let's find first the unit vector of this direction vector. The unit vector will be the 1 over the magnitude of this direction vector, 3i minus 4j, which is 1 over square root 3 square plus minus 4 square, which is 1 over square root 25, which is 1 over 5. So I know that the position my unit vector is 1 over 5. Now to produce my direction vector, I just need to multiply the position vector, the magnitude of the velocity of the particle times the position vector times my direction vector, 3 minus 4. So basically this is going to be 2 times 3 minus 4, which is 6 minus 8. So basically the position vector at t time, it will be 6 minus 8. And if I want to write it with the base vectors, I can write it 3i plus j plus t times 6i minus 8j. Now the next question, find the position when t is 4. B, when t is 4. So my particle has position vector, direction vector, basically has a formula which is 3i plus j plus t times 6I minus 8j. Now I can just substitute in my equation 4. So basically it's going to be y plus j plus 4 times 6I minus 8j, which is 3I plus j plus 24I minus 32j, which is 27I minus 31j. Now let me see the next question. The distance from the origin at t equals 4. So I want the distance from the origin when t is 4. But when t is 4, from the previous question, I found that this is the vector of the position. So basically I just need to take the magnitude of that, minus 31j, which is the square root of 27 square plus 31 square, which is equals with 41.1 meters. Last question. The distance traveled in the first 4 seconds. Now this is a very easy question, because they ask me the distance traveled in the first 4 seconds. I know that at the beginning t, when time is 0, it's here. And then after some time, the particle is moving 10 meters per second in this direction. So how many seconds I need? 4 seconds. So basically the distance will be 4 times 10 meters per second, which is 40 meters.